Hey everybody, it's the new year and I'd like to dedicate some time to doing some videos on the rotation of the Earth, or the movement of the Earth, the orbit of the Earth. Actually, of course, we know we're not moving at all, but that's the point. I want to show that we're not moving. But while I'm in the process of showing that the Earth is not moving, not rotating, or any other kind of movement, I want to show Ball Earth believers what they believe. For instance, they like to straw man with p-brane. When you're traveling in an airplane, do you notice it, p-brane? Do you feel the movement? Okay, so that's their straw man, because it's nowhere near being the same thing. Okay, so that's a false equivalence logical fallacy, right? Because the Earth is not just rotating, it's orbiting the sun, and it's flying through the cosmos at all kinds of speeds, and yes, it's actually speeding up and slowing down. Now, when you press a spinning ball Earth believer and ask them, well, do you feel acceleration? They will admit and say, yes, they would feel acceleration, right? But they don't think the Earth is accelerating. Well, I'm going to show them it is accelerating. So let me ask you something. Right now, does anybody feel the Earth moving? Well, if you do, get low. Like my little graphic says here, get low, because you may be passing out. But the reason I'm asking this is right now, in this first week of January, is when the Earth is supposedly, in its orbit, going its fastest orbital speed. Okay, and that's what I want to get into right here. We are orbiting in an ellipse, right? We're about 3 million miles or so closer to the sun at Perihelion, and as per Kepler's area laws, we're sweeping out equal area and equal time, and being that we're closer to the sun causes that ellipse to be a little bit, that area to be spread out a little more, and so it's a further distance that the Earth has to travel. Kind of, as it gets closer to the sun, it gets kind of slingshot around the sun. And then there's that moment of pivotal point in an ellipse, right at where the ellipse gets, the circle gets squashed, so it's the tighter turns on the circle. And right there is where we go through periapsis, and that's the pivotal point of directional change, and that's where we go the fastest. So, does anybody feel it? Now, a lot of ball earthers say, those that support the spinning ball Earth and have channels dedicated to it and fight it, and the commenters, they say that when you asked about, can you feel the motion of the Earth, they say, well, they could feel acceleration, but they claim the Earth doesn't accelerate. Well, yes, it does. Right here. And right now. The first week of January, that's when the Earth is supposedly moving at its fastest orbital speed and negotiating its tightest turn. Now, the 66,000 mile per hour orbital speed, that's an average speed. So the Earth is moving really fast right now. Do you feel it? So the Earth speeds up and slows down. It speeds up through perihelion and slows down at aphelion, which is on the other side, furthest from the sun. We'll experience that in the summer. That's a slowdown. Okay, and when you add the rotation into the orbit, especially at periapsis, the fastest orbiting speed plus the pivotal point of directional change, you have to add 1,000 miles per hour. If you're on the outside and you're rotating in the orbital direction, then when you're on the inside, you're rotating against the orbital direction, you'd have to subtract 1,000 miles per hour. That's a 2,000 mile per hour fluctuation every 12 hours, every day of the year. You don't believe this is a concept? Well, let's look at how a hurricane operates. Okay, a hurricane, you could think of it as a spinning, orbiting Earth. And let's say this storm has 100 mile per hour rotational speed. Well, it also has a linear speed, or the speed that the storm is moving relative to the ground, right? It's forward progress. That speed, let's say, is 20 miles per hour. On the right-hand side of the storm, you'd have a 120 mile per hour wind, because you have the 100 mile per hour rotation plus the 20 mile per hour speed that the storm is moving. You add those together. Okay, on the left side, the winds are rotating against the orbital direction, if you will. You subtract the 20 mile per hour forward speed of the storm from the 100 mile per hour rotational speed, and you get 80 miles per hour on the left-hand side of the storm, the much weaker part of the storm. Clearly, this would have an impact on the Earth and its inhabitants if, in fact, we were orbiting and rotating. So this is it. If you're ever going to feel the movement of the Earth, either the rotation or the orbit, now's the time. This is when the Earth is supposedly moving its fastest. It's accelerated and accelerating as it goes through periapsis. And this is the point of directional change in an ellipse, right? Which the orbit around the sun is elliptical because we're 3 million miles closer to it on this end than we are 6 months from now. As per Kepler's area laws, the Earth speeds up. And so if you're ever going to feel it, would be now. But of course, they're going to say, oh, you can't feel it. And I'd say, well, it's accelerating. You guys have said that if you could feel acceleration. Yeah, but this is so gradual, p-brane, you just can't feel it. Well, let me give you a little heads up. The Earth evidently feels it, right? The Earth is said to be squashing at the poles many miles and bulging at the equator 14 laughable miles high. That's rock, dirt, mud. All of this is being pushed outward by centrifugal force. It's being forced upward 14 miles high. Yet the water most easily moved, easily disturbed, can look like this? Glass? No, my friends. This is gaslighting. This is fake. Maybe you should look into this. A lot of times I get up in the morning on Ball Earthers and I go out to the ocean and I can see that it's calm as glass, because you know what? I think the Earth stops rotating at night. Yeah. And so scenes like this with mirrored water, this is not possible, because if the ground is bulging 14 miles high, the water's got to be moving to the equator. That's how physics of a spinning ball with water on it, that's what the water does. It moves to the equator because water wants to go in a straight line. And so in order to stay on the ball as we see it, in which you guys hijacked our reality and are calling it a spinning ball, the only way to see calm, placid water is that the water has to be turning with the ball. There's only one place on the Earth where water doesn't have to turn, and that's on the equator, on your spinning ball. Everywhere else, the water has to make a turn. It can't, it's not, and scenes like this completely bust the spinning ball. And again, happy periapsis. This is the time you should feel the Earth, and remember my meme here, right? If you feel the Earth spin, get low to the ground. You're probably about to faint and fall down. All right? Okay, everybody. Looking forward to some more videos on the rotation of the Earth. Stay tuned. They're coming. All right. Talk to you later. Bye-bye.